Hi Michael, I am Changhua from Team RoboGo. Today I will be presenting on the software design documents for our hazard removing robot projects. Okay, so let me just go through the content for this presentation. I will go through with you the introduction, the system overview, system architecture, and also the component design, the data design, design details, human interface design, and also the resource required, be it hardware or software. Okay, so for the introduction, basically the software design documents provide a very comprehensive and detailed information on the design of the entire software, and is mainly used by the developers and also the quality assurance team. So the quality assurance team will make use of this document to ensure that what is developed is according to what has been set in these documents, and so that they know that this solution has not gone off the track and is in line with this document, which is discussed with came out with the team. So the developer will make use of this document in particularly to know exactly what to develop and what is the functions and all the buttons and UI and the design of the GUI which is required for the system to work. So yeah, so the system overview of this entire solution is that we have a GUI monitoring controlling system and the Lego Mindstorm EV3 robots, which is the physical hardware. So the GUI monitoring and controlling system will be the application that the operator or the users will be using. Okay, next we will talk about the system architecture and component design. Basically, I will break them into two parts to talk about that. So first, I will go through with you the system architecture. So as you can see from this image, it's fairly clear that there are, of course, we are adopting the model view controller, or in short, the MVC design, which gives us better controls over not only our codes, and also in terms of implementation, it will be much cleaner as the functions are all separated and each of the components, for example, the controller, the model, and the view, does these different jobs in handling what is the outcome or output in terms of taking inputs. So let's take a look at this diagram in particular. When the users, of course, it will see from the view, which is the GUI, the graphic user interface. And so on the GUI, there are actually a lot of buttons and functions like menu bars and also the power on and off buttons. So all this, there's actually a function behind it, which actually when the user clicks on each of this individual GUI, it will cause the function behind it, which will be using the controller to accept all the inputs from the user. And based on the input, the controller will then forward the request from the user to the models model will be where all the data manipulation and processing is being done. So once the processing is being done, it will in turn updates the view, and of course it will translate to the user seeing a change in the view. So for example, when simple example, when the user clicks on the power button, okay, then it will trigger the controller, and the controller will know that, oh, it's the power button, and it will take in the IP address of the robot. So it will then pass on to model, and model will be in charge of doing the connection between the robot, establishing the connection with the robot, and if it senses that it has successfully established the connection with the robot, it will then update the view, which in turn translates to the power button from red, it will become green color. So once the user sees that it's actually green color, he or she will be able to know that the robot is actually connected successfully. Okay, so next we will move on to the component design. So in terms of the component design, basically we will let the host, which is the client side, which is the PC or the computer, to do most of the processing, as you can see from this diagram. And the robot will just be in charge of the navigation, which is in terms of returning back the feedbacks from the sensor, in terms of the light sensor, the optical detection sensor, and so on and so forth. So because the host is actually more powerful, so in terms of the physical hardware, so we will let the host be doing most of the functions like XML parsing and writing, and also updating of the map, and also all the algorithm, the A-star search and everything. So this will be the component design for our RoboGo software. So next, I'll talk about the data design. So in terms of data design, they are actually using XML text to represent each of the information. So all this will be stored in an XML file where it will be stored and all the data will be represented in different text. So over here, as you can see, there are multiple texts that we will be using, and I'll be running through each of the individual tabs with you to tell you what is the function of each of the text. So first, I'll talk about the map. Okay, map will be, in general, it could contain from the start to the end of all the information of this particular save or this map that you're looking at. So map will always be at the start in the first line to the end of the last line. So in between will be all the information that we will be storing. Okay, next, we have the boundary, which will set the map size. So basically, this boundary will give us a overview of how many grids or how long is the boundary of the map supposed to be. So in terms of over here, if you can see that we uses the X and Y coordinates to determine the start and the end, and of course if there is 4 points over here, it will state the four corners of the boundary. So it will be in a square or rectangular size. Okay, next we have the road. So road will consist of coordinates in terms of where the robots travel. So as you can see over here, there is the street, there is the orientation. Okay, so there is different orientation, and the robot this will determine the path that is available for the robot to travel. So it will take into consideration things like your no-go zone and the obstacles. Okay, next we have the robot status. So the robot status consists of its starting position and the current heading position, which means that which direction is the robot facing currently. So as you can see from the heading and the direction value is east. So it will be facing the right side on the start. And which position in terms of the grid X and Y, then we will the program will read in, and it will print the RoboGo icon on the map. Okay, next we'll have the zone. So we have various zones. We have the no-go zone, we have the obstacle zone. So this zone type will determine what is the zone about, and of course the following coordinates will determine where exactly the no-go zone is at on the map. And also we have the car, which is the hazard, and of course the car, there's only one location, so we have only 1 point over here. Then we have the destination, which is where the robot will be picking up the hazard and putting it to which destination. So that will be this destination meaning. Okay, so next we'll move on to the design details. So the design details, we have the class diagram and sequence diagram. So the class diagram is more like an overview and it's more technical, and the sequence diagram will shows you some of the flows of how certain function will work. So let me just go through the class diagram first. Okay, this diagram is not the full diagram, it's actually part of it, as the whole diagram is actually very big. So but the concept of this class diagram will be, as you can see over here, okay, there are each individual classes, and each individual classes, they has their variable and has their functions. So all these functions, different other classes from other places will be able to call, and they will retrieve certain values that is required. So this in turn gives the developer a very good idea of how to develop the entire system by looking at this class diagram, as it consists of all the necessary function that is required by the developer. Okay, so next we'll move on to the sequence diagram. Okay, so for sequence diagram, as you can see, the first one will be the robot connection. So the robot connection consists of the operators, the GUI, and the robot. So when the robot when the user wants to establish a connection, it will enter the IP address, and the connection will be sent to the GUI, and of course the establishment of the connection will be to the robot. And once it's established, it will have a beep sound, and there will be the power button will change color. Next will be the map loading. So in terms of map loading, it's actually meaning to load the XML map, which is the starting map of the for the RoboGo application. So the operators will use the XML and load from the menu bar, and it will load into the CD map, and it will be displayed on the GUI. And from there, the user will be able to set their initial position and header position and safe drop zone from there. So basically, the user has to load the XML first, and then they can do the other functions. So the next one will be the robot will set the no-go zone. So basically, the robot has to click on the no-go zone button, and then they can select on the tiles where are the no-go zone, and after that they will click on done. So when it click on done, the robot will read in all the values, and it will be used for the calculation later on for the pathfinding when they go into the auto mode. Okay, next will be the robot operation mode. So there are basically two kinds of mode that the robot can operate in. One is auto and one is manual. So basically there will be two radio buttons that the user can select. So auto will send a request to the GUI, and it will tell the robot that, oh, you are going to the auto mode, and the robot will start moving by itself with all the pathfinding and all the values given to the robot, so that the robot will be able to function by itself and reach the destination. In terms of manual, we will be able to override, and we will be able to use the control buttons, for example, forward, turn left, turn right, backwards, and of course lift the lever, lower the lever. So all these functions will be available during the manual mode. Then next, we'll go into the human interface design. So the overview over here will be that there are a few components. There are the menu bars, which at the top, the map section, robot control, robot indicator, and event log. So let's take a look at exactly how does the overall human interface design looks like. So this will be how it will look like, with the menu bar on the top, the robot control on the right side, robot indicator, and event log, and of course the entire map will be over here. This view that we are looking at is after the XML has been loaded. So next we have the menu bar. So the menu bar, there's three functions basically. One is a file, one is edit, and one is help. And each of the individual menu bar, when you open it, there's a sub menu bar which has various functions, as you can see from the image over here. Okay, next will be the map section. So the map section consists of the robot icon, and of course the entire boundary of the road and the map. So the black lines in between will be the roads that the robot can traverse. Okay, so this will look like once the robot has traveled a fair bit of distance. So the blue lines will symbolize that these are the paths that the robot has already traversed. Okay, next will be the robot control. So basically the robot has a lot of controls over. The robot control there's a connection button, there's an IP address field. So the connection button at the start will be disconnected. All you need to do is just fill in the IP address and click on the button. Once it's connected, it will turn to green with the relevant status change. Next, I'm going to talk about the robot control. So the robot control has actually the robot navigation portion, which is the up, down, left, right arrows that you can see over here from the GUI, from the image. And also there is the lever control. So basically you can lift and lower the lever, and you can set the no-go zone or clear the no-go zone. These are all available in the manual mode. And also there is the control mode, where you can set the auto and manual, and there's a stop control button over at the side there. So for you to click in case you need to stop the robot during the auto mode. So next will be the robot indicator. As you can see over here, there is currently 4 kinds of indication that we will show. One is the battery level. Another one is the control mode, can be auto, can be manual. The location, the current location of the robot, and the speed that the robot is traveling at. Okay, so next we will be talking about the event log. Okay, so for event log, basically there is information that will display once you moves the robot, or there is anything that happens to the robot. For example, if the robot turns right, there will be a event log of robot has turned right to indicate to the user that what is the action that has been taken. Okay, next we'll talk about the resource estimate, or rather what are the resource that is required for this project or this RoboGo application. So there are two components, basically the hardware and the software. For the hardware, we'll split out into the host side and the robot side. So the hardware for the host side, basically it has to be Windows 7 and above, and of course the basic processor of 2 GHz, memory 2 gig of RAM, and the storage of 16 gig, and also the display has to be at least at the dimension, the pixel that you see over there, which is 1366 by 768 pixel. So next, for the robot, basically it has to run on the Legos EV3 version 0.9.0 and above. And also, and I believe that the processor, the memory, and the display should be fairly standard when you purchase the robot, and it should come with it. So, and next will be the software. So for software, we need to have a Java JDK 7 and above, and also the Legos EV3 version so that we can connect to the robot. And Apache N version 1.9.6 and above, the Eclipse, which is the development tools that we use to develop the software to talk to the robot, and also to display the map, and the Legos plugin for the Eclipse so that we can access to the API for the robot. So with that, I come to the end of my presentation. I hope that it gives you a good overview of the SDD, in terms of the SDD for this project, and what are the designs and what are the relevant information that is required for this project. So with that, I thank you for watching this presentation. Goodbye.